So a particle, sorry, a source is moving on a circular track with angular velocity omega, radius is r, and we are supposed to find the maximum and the minimum frequency heard by the observer. So the maximum will be heard when the source is moving towards the observer, which is the tangential position. So they may ask you multiple questions like to find the time from here to there. So we need to find this angle and we're done. So they generally give the distance. So this angle, if I call theta, then theta equals to omega into 10. So you can find theta, the t as theta by omega. And you can find the theta. It's not very difficult using whatever mathematics you want to apply. If I choose this as alpha and if I call this as r, this is basically sine alpha, r by d, and alpha becomes sine inverse r by d. And because this is alpha, this is 90 minus alpha, so theta will be 180 minus 2, right?
Yes, sir.
So they may give you the d as a suitable value. Let's say they may give you d equals to 2r, so it becomes 30 degree, which is very nice answer, and you can solve. So I think we're done with the this part. Now you can go to the beats question. So let's say we have a source, and the source is maybe mounted on a trolley, a truck, car, whatever, and the trolley is moving towards right with velocity vc. So this speaker will emit the frequency. So moving forward, there is a wall, and the driver of the car so driver of the car will listen to two frequency, one frequency which is directly heard, and other will be the frequency which will come to him after reflection from the wall. So because if that sound is coming this way, there is no relative motion between the driver and the source. So what frequency he will hear is f only. But the frequency that he will hear because of the reflection will be f dash, maybe f double dash. So this will change the frequency. And therefore, the driver of the car will hear a beat frequency. So we are supposed to find what is the beat frequency. So find so driver will actually hear two frequency, one directly and another through after reflection. And because these two frequencies differ in value, so the difference will be called the beat frequency, and that's the question. There are two methods to solve. So I'll show you both the method. So in the first method, Imagine the wall as a listener. So if the wall is like a listener, so the source is coming towards the wall. So it is like the listener is going to listen to the bigger frequency. So what is f dash value? You can find f dash. So observer at rest, source is coming towards. Can be write like this.
Yes, sir.
In the second scenario, the driver of the car is approaching a. So now after hitting, this will become itself like a source, a virtual source. So now it will emit the sound of value f dash. And now this driver is approaching it with velocity v. So now he will listen to the new frequency f double dash. F double dash is like the listener is moving towards the stationary source. So V plus Vc upon V, because source is stationary, into f dash. And f dash we have already calculated, so we can write f double dash equals to. So the definition of the beat frequency is how much? F double dash minus f, isn't it? You can take modulus, but we are taking the positive value. F double dash is how much? You can see the beat frequency turns out to be this value. So generally what they give is they give the beat frequency value and original frequency. They will ask you find the speed of car. Sometimes they will tell you that okay, the wall is made of glass and there is a concept of resonance. It means if the glass frequency will match the frequency received, it will break. So what is the velocity of the car which will break the glass if the breaking frequency is known to us? So let's say if we mention that the natural frequency of the glass, this wall is f naught. So the moment f dash becomes f naught, if f dash equals to f naught, wall will collapse. F naught is called the natural frequency of wall. Method two is you can treat the wall as a mirror Then if I choose the driver as the observer, then the source will also appear as a something moving towards the wall. And because the velocity of both are same and both are approaching, so we know f dash, I'm just writing only one value. So f dash equals to the numerator will add up and the denominator will subtract to get the maximum value, right? Because they are approaching each other, so v plus v naught upon v minus vs. Because v naught vs both are same, you can say this is acting as a v naught, this is acting as a vs, and therefore you can take the source and the observer as a image pair, and you can just solve this question, and now you can directly find the b equals to f dash minus f dash. You can solve any problem just like this. Click the image and solve. If source and medium are in two different, if source and object are in two different medium, the frequency never changes while crossing the medium. What changes is the wavelength and speed, not the frequency. So keep in mind that while wave travels from one medium to another medium, so while wave travels from one medium to another medium, its frequency remains same. So maybe in some question you need to know this fact and then apply it, but the wavelength will change. So wavelength in a medium is defined as wavelength in air upon mu of medium, and similarly the velocity will be v in vacuum or air upon mu, and therefore the frequency is defined as v by lambda. So it has nothing to do with the mu term. So it is still the same. Understand? So even if you write a v medium by lambda medium, you can see the answer is v air by lambda air. So that's why this is the constant quantity. This is what I'm trying to do. So frequency is the characteristic property which remains unaltered while crossing the medium. So you can also apply the Doppler effect of two object in a source when they belong to two different mediums. So let's say we may have a water on one side, maybe some ocean, and maybe some sources coming this way. And the observer listener. So listener is moving, let's say V naught, and the refractive index of medium is mu. Okay. So you have to use the concept of optics that if we have two different medium, then what is the apparent velocity of these two parts? Okay. So what is the wavelength it will receive, and so on. So if the wavelength in air is lambda naught, the wavelength in the medium will be, so by default the wavelength will decrease, and further by virtue of motion, so the by virtue of motion of source, the wavelength will anyway gets decreased lambda dash, which we write as V minus V source into T. If you remember, the wavelength will change to a new value because of motion, and this value will change. So when going inside for I can think this part, ignore this part. Anyway, so first of all, the lambda will change this value because of the motion of the source itself. So now the two crests will be nearby, and then this will enter this. So the lambda inside the medium will change to lambda dash y. And now you have to think this way, that this will act as a source, and this source is emitting wavelength of value lambda dash y. And now you can think that what will be the frequency, and at what speed it is coming. So the velocity with which the wave will propagate will be Vs by mu, not V so mu. Let's say lambda we got, and we know F is F. So the velocity of sound in medium will be, okay. That's the difference. Sorry. So we have to use the velocity of sound in that medium. First of all, it will receive the frequency dash, and this will transmit the same frequency into the medium. And then, okay, transmission to the bottom. Okay, I will analyze this later on. Let's see. So now we can go for the last topic, which is called the reflection of wave by a boundary. separating two media. So reflection of wave by boundary separating two media. Okay. So imagine we have boundary and there are two types of media. So any wave coming to the boundary, it's a traveling wave. So this traveling wave is coming towards this boundary. So once it will hit the boundary, a part of this energy will go into the field. So this wave is coming and you can see it will have some amplitude of oscillation. Let's call it A. And better we call AI, the incident wave amplitude. But at the boundary, some energy will redistribute. So a part of energy will go on the other side. So what you will see that energy will go this side, a part of it, and therefore the amplitude of this transmitted wave will be AT, and some energy will reflect back. And so the amplitude of this wave we call AR. And why we need to choose different values? Because the energy is getting redistributed. So some energy will transmit, some energy will reflect. So this is, if you think the wave as the incident energy, this is the incident energy, then this will be the uh, this will be the reflected energy, and this is your transmitted energy. Is this clear?
Yes.
So every wave will follow the equation of continuity, which says that. So there are two rules that they need to follow. So at the boundary, if we think of a particle, so any particle at the boundary will be oscillated by on the right side by the transmitted wave, but on the left side by, so who will oscillate on the left side? It is the incident and the reflected, right? So the net displacement of the particle on the left of the boundary will be equals to yi plus yr. But the same particle on the right will be oscillated by the yt itself. And because a particle cannot have two different oscillations, so continuity equation says that, so continuity equation implies that yi plus yr equals to yt. So we call it the first equation. And also the direction of velocity vector must be same. So the way we derive the direction is the, so del by del x of the yi plus yr must be equals to del by del x of So the first equation is the continuity in terms of direction of motion, in terms of displacement value, and second is in terms of direction, because displacement values are same as well as they are moving in the same direction because of the boundary conditions. So these two are called the two boundary conditions for wave, and we need to solve these two conditions. So for simplicity, we'll choose the boundary as x equals to 0, and then we'll learn how to write the equation first. So the first equation called the incident equation. You can write as AI sine omega, we can take common t minus x by v1. Now why v1? Because we have two mediums, so velocity of the wave in the two medium will be different. The reflected one will have this amplitude, and because the reflected is going left, so the equation will be t plus x by v1. Why v1? Because it's moving in the same medium. Now when it comes to the transmitted equation, it will have direction same as the incident one, so minus, but it is moving in a different medium, so it will be big. So we prefer writing like this. So we have three questions, and what you are supposed to do is you're supposed to use the equation of continuity and the boundary. We basically can say this as boundary condition. So yi plus yr equals to yt, which is like ai. So if I call equation one, put x equals to 0. If you put x equals to 0, what you get? Ai sin omega t, ar sin omega t, and at sin omega, which will eventually give you the relation of amplitude, which is ai plus er is always equals to 8. So what about the second one? So can you differentiate the question one? So differentiate
Yes.
question one with respect to x. We have. So you first differentiate and then equal to 0, then equate x to 0, you get one another equation. Can you tell me that equation after solving? Anybody there?
So sorry.
Yeah, please try and do it.
So after differentiating module,
Yes, tell me.
after differentiating, you have to just put x equals 0.
Yeah, after differentiating, again put x equals 0, you get the answer. If you differentiate with x, you will get minus a by vi, v1. Okay, after putting x and putting 0 also. Plus
So
ar
it's
by v.
minus a by.
If this is your answer, then that's correct.
Yes, this one.
Very good. So you can write as ai minus ar. Let's call this as a question 2 and the question 3. So solving 2 and 3, you can get the value of AR and AT in terms of AI. So you will get something into AI. Can you find the something part?
2 divided by 1 plus b1 by b2.
So what is the AR part? Yeah, so
So
the
AR is an antonym of A2.
okay, AT is how much?
2 times
2
2
times
divided by 1 plus b1 by b2.
1 plus.
b1 by b2.
Okay. So you can rearrange properly. It will come 2 B.
2b2 by b1 plus b2.
Very good. What about this one?
Also AI bracket
Hmm.
v1 minus v2 by v1 plus v2.
Is it 1 minus 2 or 2 minus 1?
v1 minus v2.
Oh, sorry. So if you divide this, you get the answer as so if I subtract and add, I'll get this number. So it is always V2 minus V1 upon V2 plus V1 into AI. Okay. So these two formulas are very, very important because if you know the intensity of the incident wave, you can find the intensity of the reflected and transmitted wave. So finally, we have the formula. So let I not be the intensity of incident wave So intensity of reflective will be what? So it will be the square of the formula, which will give you V2 minus V1. And the transmitted will be the next most important concept in wave motion is concept of phase shift. So phase shift only occurs for reflection. Transmission never shifts the phase. As you can see, the AI, the AR is having this formula, but AT will have the formula just like this. So the sign of AT and AI cannot be opposite. They must have same sign because this is always a positive number, right? So if AI is positive, you can think that way. AT is positive. If AI is negative, AT is negative. So they are in phase. So as a note, transmitted wave always remains in phase with incident wave. Now reflected wave is having the V2 minus V1. So V2 may be less than V1, V2 may be more than V1. So when V2 will be less than V1, if the other medium is, if the medium on the second side is denser, so the denser and rarer need not to be physical density. When we say denser and rare, we mean actually the velocity of wave in that medium. So a medium in which a wave can move faster is called rarer medium, and medium in which wave can move slower compared to the other medium, which is called relatively rarer medium. So the denser and rarer medium is defined in terms of speed, not in terms of physical density. Please keep in mind. If V2 is more than V1, what will happen? So what does it mean? The V2 is more than V1 means medium 2 is rarer compared to
Medium.
Medium one. So when reflection happens from the relatively rarer medium, phase shift doesn't occur. So AR and AI will be in phase. समझे क्या? These two will be in phase. But if V2 is less than V1, the other medium is denser one. If V2 is less than V1, then the AR will be negative. I mean, AR will be heavy. So AR and AI will be out of phase. So imagine if you have a steel rod and the sound wave is coming like this. Let's we have tuning for. So which medium is denser? Hmm? Which medium is denser?
So the second one is dense.
Hmm?
Second medium two is dense.
So here air is denser medium. The velocity of sound in air is roughly 340 meter per second.
Call from +918779131514.
But the velocity of sound in steel is roughly 5 kilometer per second. So for sound, it can move faster in which medium? Steel. Because it can move faster in a medium called steel. So for the sound, the steel is behaving as a rarer medium. So when a wave will hit the rarer medium, the phase will not shift. And that is why every longitudinal wave, upon hitting a rigid boundary, will maintain the phase. No shift will occur. It's the other way around. If we have, let's say, a dholak or tabla with a diaphragm or a membrane, which will act as the maybe rare medium and then well, act as a denser medium and it will change the phase. We'll see that. So here, upon reflection, phase shift will not occur. So in this case, there is no phase shift. Clear? In case of string, let's say we have two string. And the other string is, let's say, slightly thicker. And if both are like kind of fixed, So if you fix the string like this, so the tension in the string we can assume as only one value. T is a constant value. But the linear mass density of the thin wire is let's say mu1 and thick wire is less than mu. Assuming mu2 is more than mu1, we know the velocity of sound or sorry, velocity of wave in a string. The answer is T by mu. As mu will increase, so here the medium 2 will act as a denser medium. So if a wave is traveling from this side, then the reflected wave, let me go. So after reflection, the new wave will just revert with less amplitude. Incident reflection. But the transmitted will go this way. So transmission will have the same phase as the incident, but the reflection will invert the phase, and that is how the wave will propagate in different medium. So phase shift will occur. Okay. This is what you need to remember. So for transverse wave, upon reflection from the denser medium, I mean the physical density and the denser medium both will appear same for transverse wave, like a heavy rope and light rope. So if you have wires, let's say aluminum wire, copper wire, then you need to know the density of the wire because the formula will be the Young's modulus of the wire upon density. So you need to know Young's modulus, and after putting the value only you can check whether it will change the phase or not. So only when you know the velocity you can decide which one is error, which one is denser. You cannot decide just by looking at the diagram. Okay. So imagine we have a wave pulse which we create. So you create a pulse like this. Let's say this is L1, this is L2, and the pulse is traveling with velocity v. Because the ends are fixed end, so whenever a transverse wave will hit a fixed end, it will always change the phase. So the wave will travel and will reach the right end, will hit the right end, will reverse. So while coming back to the same point, so while you pass the same location, in fact, it not just passing at throughout the journey, it will travel this way. Again, it will hit the left, and then again it will change the phase further. Now in the next journey, yeah, that's the question. The question is this one. So from the moment you start and the moment you again go back in the same direction, how much time has been spent? So t is how much? Can you calculate the t value? You travel L2, then L2, then L1, then how much? How much you travel to go from here to here? The wave will go here, will hit, will come back here, and then will come here. So you go L2, then you go L1 plus L2, and then again you go L1. So the time will be a very simple answer. Twice L1 plus L2 by. Questions like this can be asked. So question will come like this. So let's say we create a transverse wave of in some random shape, okay, it's a triangular shape. There is a wall here. So dimensionally, the height we keep in millimeters. Let's say height is 1 millimeter. Don't scale, and this length is 1 centimeter. And the distance from here to here. So this distance is let's say okay, 10 centimeters. So plot the graph at t equals to 10 seconds and 11. So how the graph will look like at 10 seconds? The shape. Can you guess? Oh, the speed is given as 1 centimeter per second. Now you can solve. So you're supposed to plot the graph. One more mistake I made actually. This relation is only for EM wave. So of course this relation is for EM wave, but the concept is same for the sound wave also. So when you change the medium, the frequency remains same. That property is for every wave, but the derivation which I gave is only for the EM wave. And just not to get confused. So at 10 seconds, imagine there is no wall. And if you imagine there is no wall, the peak will be like this, correct? So at 10 seconds, the peak will be here, isn't it?
Yes, sir.
But the part which is on the right side will suffer reflection with phase shift also, which means the part on the right will first appear on the left. So you can take the mirror image. So there is this simple rule. First, you invert the portion on the right of the wall. So you invert it. So invert like this. So inversion, why inversion? Because phase shift. So we are inverting due to phase shift. Invert due to phase shift. And then reflect because the wave will not go on that side. So the other half will appear here exactly below the remaining half. And then what we do is we do the superposition and we only check the end value. So this end is having 0 and 0. Upper wave is 0 and lower is 0. So the net sum is 0. The right end is A above or 1 mm above. This is 1 mm below. The net is again 0. Because we know the two ends, so the wave will appear flat. Which means at t equals to 10 seconds, you will not see any shape. You will see a flat thread. Understood? The rope will be flat at that instant. But exactly at 11 second, what will happen? At 11 seconds, the entire wave will be on the right. So by the time it is 11, the wave has reached here. So you have to do the same process. Invert and reflect. And there is no one to superimpose. So this is the answer. So at 11 seconds, the wave will be here. This is the answer. Understood? Things will change at 11 seconds. Is this clear?
Yes, sir.
So let's do the problem, few more problems to get the hang of it. So if we have a wave of this shape, okay, I should have made it equal, but anyway. So technically, this is 1 centimeter and this is also 1 centimeter. And the full height is this is 1 mm and this is 1 mm. It's like full height is 2 mm. And the distance of the peak from the wall, you can assume whatever value you want, let's say 10 centimeter. And the velocity of the wave is 1 centimeter per second. So draw graph at t equals to 10 seconds and 11 seconds. Try this out, then I'll see. So you can try it, then when I will solve those questions, you can see whether your answer is correct.
Yes.
So do it.
That's
Just Okay, so once you draw this, you can see the graph is something like this, and the small portion is like this, right? So we can take this part reflection, inversion and reflection, right? So what you can see that 0 plus 0 is 0, but plus 2 and minus 1 is 1. This is your final graph. Is this your answer?
Yes, sir. Serial ones.
Can you see the answer? No. The part which is inside the wall will invert and reflect, right? And what we do is we superimpose the reflected part from the actual incoming part. So this point will be 0 and 0 for both, so 0, and this point will have 2 above, 1 below, net is 1. And you join the two extreme to get the net shape. So the shape will be like this. This is the shape, final shape. It is clear?
Yes, sir. Understood.
I think nothing is left in the chapter. Just take a confirm. Okay. So the last concept is called this is very important from the point of view of JE mains. Doppler effect in light. So in light, we have something called Vibgyor. So when a wavelength will increase, so if the shift, let's say this is a wavelength, and if you shift towards this way, we call it a red shift. And if you shift this way, it's called blue shift. So let's say if you have a laser, and if you flash the laser towards a wall, or let's say towards a mirror, and then the laser will hit the mirror, will reflect back. So you will get the same wavelength. But imagine the mirror is moving towards you. Then the reflected light will hit the moving part and then will come back. In such scenario, the wavelength will shift. Okay. And because the wavelength will shift, so it will either increase or decrease. If it will decrease, we say blue shift, and if it increases, we say it red shift. As you can see in the diagram, the decrease is the blue shift and increase is the red shift.
Yes.
Now the formula is quite different, and there's unique situation here that in case of light, source and observer source and observer's relative velocity matters, not the individual values. So if you remember earlier, we used to have the Vs and Vo. Now this is not used here. We only use Vr, which may be Vs plus minus V. If they are moving towards each other or going away from each other, so we can just add it. If they move in the same direction, we subtract it. That's it. So the VR is the way to solve. We don't take Vs and Vo at all. And the formula for frequency is given by under root of velocity of light plus minus VR plus minus VR. That's it. So if the source and observer are coming closer, so here we have only two situations. If source and observer approach each other, the answer becomes C plus VR by C minus VR into F. That's it. If we recede from each other, so the concept of Big Bang theory, which talks about the expansion of universe. So the Big Bang theory was proven because in the experiment when we projected the laser torch or laser beam to a distant planet, and when the beam came back to the Earth, the lambda received was different from the lambda projected, and that is only possible when there is a relative motion. And because the lambda received was bigger than the lambda projected, so there was a kind of red shift which confirmed that they are receding from each other, and that was the like the kind of confirmation that Big Bang theory is correct. The universe is expanding. So that is a theory. I mean, there of course there are many controversies, and the experiment performed is also controversial only. But nevertheless, this is what we have in our syllabus. We will stick to that. So the f dash is having this formula. So if I choose any one formula, let's just choose any formula. So velocity of light is very high, and therefore I can take c common. So it will become 1 plus vr 1 minus vr by c, and this you can further write as from binomial approximation. So if you take the d numerator in the numerator side, and so the we can use binomial, it will come inside, so it will become 1 plus, and so this power gets cancelled. F dash is f plus vr by c into f, and I can take f this side, so f dash minus f, or the frequency shift. So delta f by f we write as vr by c. You can choose plus or minus, that's all. So we derive from one particular case. In general, we write vr by c. Okay. So change in frequency of the observed and the transmitted upon the original frequency is the relative velocity of the source and observer upon speed of light. We know that f equals to c lambda. So the delta f equals to c delta lambda. So delta f by whatever C equals to F lambda. You can just differentiate this. Delta A by A plus delta lambda by lambda equals to 0. Delta lambda by lambda is, so fraction wise they are same, just sign will be opposite, that which is logical. So if frequency will increase, lambda must decrease and so on. Okay, it's minus plus will be others. We can also add delta lambda by lambda equals to, only it's a matter of a sign. Numerical value we can calculate easily, and from logic you can understand delta lambda should be positive or negative. So no need to take the sign. So just add the formula. Okay. So this is a shift problem, and if they ask the frequency, they will give you the so if I say VR equals to 0.5C, then F dash will be how much? This comes to 1.5C. This is root 3F, right? So the new frequency will be root 3 times the old frequency. Okay. So no, that's not the case in general, because nothing is moving even close to C by any value. So even the 1/10 of a velocity of light is also something a distant dream. So these shifts are very small technically. It is not very easy to observe. Okay. So you will get a lot of question based on the Doppler effect in your HSC textbook of class 12. So you can also make a reading from the book itself. HSC textbooks are also very good in terms of reading. They have quite a good content, theoretical content in some of the chapters, not all. Especially in the modern phase part, they have given a lot of good theory, and one should read that. Okay.
Yes, sir.
So this is the case of approaching. That's why the numerator is plus and denominator is minus. If they are receding, then it will reverse. So now we're done with the wave and sound completely. Then again, I can teach something. Okay, I left with one more idea. So in beads, there is something called waxing and waning. They also called loading,
Sir, waxing and what?
waning, W-A-N-N-I. Loading and filing. You might have heard about the filer. So when you cut your nail, there is a blade given with a scratch, which you rub against the nail to make it smoother, right? That's called filer. Okay. You might have seen a nail cutter will have a grooving part.
Yes, sir.
This is called filer. It will like a kind of a scratcher. It will scratch the surface of nail. So if you have a tuning fork, so waxing will decrease the frequency. So if it is having frequency F, so if you load wax, it will have frequency F. dash, which will be less than, and the filing, if you file, it will grow in frequency because you will make it lighter. So if filing means you remove the part of it, so you're making it lighter, so it will grow outside very fast. So what you need to remember is that loading or waxing decreases the frequency of oscillation of tuning fork, and vanning or filing increases the frequency of tuning fork. So just remember these two facts. Loading with wax decreases the frequency of tuning fork. Filing increases the frequency of tuning fork. Okay. So how they will ask a question like, so example one. So you say we have two tuning fork, 1 and 2, and the frequency of the first is 256 hertz. The second is unknown, and the beat frequency is 4 hertz. So these two things are given. So if beat is given, what does it mean? What is the meaning of beat frequency? The difference of frequency is how much? 4 hertz. Because the difference of frequency is 4 hertz, so F2 may be
252.
either 260 hertz or
252.
so we need to check, like we need to actually understand like what is the actual frequency. So what we do is now we have two options. We have to eliminate the one. So we either wax or van any one of them. So let's say let wax 1. If you wax 1, the frequency of the first tuning fork will decrease or increase. Then F1 dash will be less than F1, right? Hello, hello.
Yes.
If you wax the first tuning fork, its frequency will decrease, yes or no?
So can you show the previous, please? Yes. F dash will decrease. Yes. So your voice is not audible.
Hello, three.
So now you are audible.
Okay, so what I asked,
So that F1 will be greater than F1 noise.
so if you wax the first unit clock, the frequency will decrease, yes or no? अरे बोलो यार, ऐसे तुम्हें पढ़ाई नहीं करना।
Yes, sir.
हाँ तो बोलने में शर्म आती है तुम्हें?
So like
I'm going to stop teaching you guys very soon. Don't worry. So the beat frequency will be, there are two possibilities. If you choose the 260 as the answer of the F2, then beat will become 5 hertz. And if you choose the 252, the beat will become 3 hertz. So earlier the beat was 4. Upon waxing, if the beat increases, we know the answer is 260 because the beat frequency we can hear. And upon the decrease of the beat frequency, we know the answer was 250. So in the question, they will give you that upon waxing or filing, the new beat frequency has increased or decreased. They mention this fact, and from there you can conclude easily that which one of the following should be the right answer. So these questions are very common in SC Verma, so that's why I have taught. And with this, we complete the chapter. So next, hopefully I should not teach, but anyway, if in case I have to teach, then I will start the chapter called thermal expansion.